The type of the quizzes are similar to what you got here, and the quizzes very easy. I know it's very easy for you, but I will give you additional sample exams, and since you are taking time and you are spending time to solve those exams, those sample questions, I'll take them as homework 2 and homework 3 to let you get more scores and more points. So it's a way to get more scores. The exam will be 1 hour, the final exam. Okay, it's not very long, and also it's just mostly questions like multiple choice or fill up questions or true-false questions, like what you see in the quizzes, which is very easy. Go over the Adventure Works database, write some queries.
No queries, Professor.
What?
No queries.
No queries.
No queries.
Is that okay?
Yes.
Do you like queries or not?
Queries. No queries. Extra.
Okay.
1, 2 queries.
One person asking for queries. Okay, but queries is good because it's a challenge. You know, like it's a competition. Like it's very challenging, and you know.
Usually, like less time taking queries, Professor. Not
What?
big ones. Less
Like
time taking.
in the mid you gave like nested and nested.
No, because queries are in the first part of the course. I don't want to ask
Just ask multiple choice.
Also, multiple choice question will be.
multiple choices. Yeah. So. You will not be asked about the physical structures, but you have to understand what physical structures are in order to answer 12 questions. Okay, so if you feel that you need more studies on physical structures, go and study that.
Professor, can you open up all the quizzes which we have done so that we can come to know what are all the wrong things we have done?
What in grades?
No, quizzes, the questions and the answers it was showing as a closed one.
Okay, so let's. People ask me to answer the quiz, so let me answer the quiz we have today.
Not this one, Professor. The old ones, all the quizzes from the start.
Is there any facility in common?
Yeah, it is there.
You can open all the quizzes. Like, we can see the correct answers and we can compare it with the.
Okay, I didn't know that. Okay, I will do it.
Okay.
So, if you know anything about Canvas, just let me know. You know, if you know anything new or some facilities. What was it? Today's quiz?
I think in.
Okay, so the quiz was very easy. You have this query which is involving 4 tables, production description, also it involves table production, product description, culture, and also it involves product model and product. Okay? 1 minute left before the quiz. Okay. So which of the following is not correct? Is not true?
Since we have right join, not right.
Okay. So what about the first one?
No.
It is true, right?
Yes.
First one, you can get. How many people executed the query? Honestly. Okay. Good job. Okay. So it's acceptable for me if you execute this. You see that the first one is definitely correct. The second one, I don't talk about the third one. We can use hash join to execute all of the joins. Is that correct? Yes. You executed and you saw that hash join is used. What about the last one?
All the tables were scanned.
All of them are supposed to. Even if you don't execute the query, you will see that all of the records should be read. So the only thing left is this one. And also, right join is not imposing any constraint for you. So consider the following query. It's a big query, but don't worry about this. We can get benefit from clustered index of salesperson table.
True.
Okay, so salesperson table is using business entity ID. Okay, business entity ID. Just go over from or where clause part. In the from where you are defining joins, go over that part and just check business. Just check whatever you are using from salesperson table. You will see that you are using business entity ID. What is business entity ID in that table? It's a part of index, primary index. Then you can use the benefit. You can get benefits of that primary index, which is cluster. Yes, this is true. Okay. Okay, so we talked about creating tables using user-defined types. For example, here we use UDT we use a student type to okay, so we use the student type over here. You can see that the student type is used over here. So, okay, so guys, you will have one or two queries from database, from object-oriented databases. Is that okay?
Like functions and use it is okay.
What?
You're giving like object oriented.
Object-oriented is simpler, you know. You just put dots and go through objects. Okay, so this is the table you are creating for a student type. If I give you object-oriented queries, it will be very simple. Okay. So here we just review that in the object-oriented databases, only tables that are containing objects have your own object ID to identify tuples. Okay, other tables do not have OID. For example, here we have a table of a student. We have a table of student 1. So table of student 1 has this structure set of row. The structure of the student type and this table is exactly similar, but since the student type is a class, then we will have OID in this table, but we will not have any OID in the second one. Okay, so we will see later reference objects, and you will see how we can use it. This is a simple query you can have in the basically object-oriented databases. So if I give you a query, it will be something like that. You know, you are asked to show the name and the grade of a person from table transcript, where if the person is if the person is residing in main street. It's very simple. You are just selecting attributes of name of object student from table T, and also grade, and the rest is as you can see here. So note that name is not a member of the student. Note it's inherited from person. So just a brief review. You can see here that we had this person type, which has this name and address, and each student is extending person type. Therefore, this object also have a name. Just very similar to Java, very similar to other object-oriented languages. So now we will talk about one more challenge here, which is updating or inserting a record, for example, to table of transcript. If we want to update or if we want to insert something to table of transcript, if you want to write the SQL query in traditional query, this is the structure. But there is a problem over here. What's that problem?
Student.
So student is object. How can I specify the object? How
Can
can
we
I
give it
say
in
that
brackets?
which is student?
Can we
So-
give it in brackets?
And in the brackets, what happens? Should I put all the information of yours? So,
Student information in the brackets, will it work?
so is it referring to a new student or is it referring a student from table of students? Which one? Suppose that I want to put a grade for Vanindra. Should I put, instead of these question marks, should I put a student of, should I create a record of Vanindra with all of the information he has and just insert that record? Or I should have a way to reference Vanindra to that table. So we will see how we can reference this. Before that, before getting to that, let's talk about basically simple primary receiving or getting back data field from the objects and also changing those objects. Before moving to this kind of complicated problem, let's talk about observer and mutator methods. Okay, so in object-oriented databases, by default, each object has this two types of methods. One is observer, which is returning the value of an attribute, and the other one is basically returning or changing or setting a new value for an attribute. So, for example, this is the syntax of the observer method. So you are familiar with this kind of syntax of explaining data types, right? You are familiar with this, are you? What does it mean in program languages? I'm sure that in program languages you have studied something like that. What does it mean in program languages?
It's method, function, argument.
It's the name of the method, the argument, the list of the argument which is empty here, and the return type. Okay? So this is exactly the same meaning over here.
Sorry, is it the lambda functions?
The lambda is also using this syntax. Also, but it's in all the programming languages, this is the syntax of defining functions, lambda or other than lambda. So observer method here, suppose that A is an attribute of type T in an object. Okay, for example, name of the person. So after SQL 1999, the DBMS is supporting default by default, adding these kinds of methods to objects, which is called observer methods. This observer method, for example, here returns the value of the age set for the student. Okay, for example, if you have an object of a student for Sudhir, then it will return the name of Sudhir for the name here. If you have name here, then it will return the name of the person. Okay. So suppose that we have this student type, then for the student type we will have these functions by default, ID, name, and so on. So then basically here by default when we are referring to an attribute, basically an observer method will be called. So in this query, when you saw this query before, t.student.name, here name is an observer method which is returning the value for you, just returning it. But here tGrade is not an observer method. Why? Any
It's
guess?
not in the student type, it's directly calling from the table. It's not in student type.
Exactly. So transcript is not a type, transcript is a table. So, but the student is a type, so this is defined just for types. Okay, so what is the mutator method?
Setter, changes the value.
Yeah, exactly. So now, Java programmers, it reminds you something. What is the concept behind this? Setters and getters, right? Exactly, setters and getters. You have something getters, observers are getters, and whatever you change a setter. So a setter, the mutator method is following this signature. You can see the signature over here. It receives a type T as an argument and returns basically it returns nothing. It returns a object U basically. So or it returns the new object. Think about this way. Suppose that you have an object for student Marikanta, then you want to name Marikanta's name to Michael. So you call his mutator, then the object Marikanta will be gone and another object will be created at the same values, except the name is the new name. So it returns a new type. So okay, so let's get back to the insert query we had. So given the fact that we have these mutators, now suppose that we want to rewrite that query we had. So assume that we are not referring, when we are inserting a record to transcript, we are not referring to a previously existing previously existing object, so we need to create a new object. So suppose that at the same time when you are adding one record to the transcript, at the same time you are adding that student also to the system. So what you need to do is you need to create new, the object new. So the object new is creating a student type. So and also you can use mutators here. Basically ID, status and names are the mutators of the new object, and also address row is the mutator of the object address. So the rest of the insert query is similar to what we had before. Rest of adding other fields, like for example we are adding a grade for Joe Public, and also we are adding Joe Public to the table of students. Okay, because we are creating a new type of a student with the name of Joe Public. His grade will be in the course CS532 will be A in the semester spring 2002. Okay.
Suppose the student is already there with the same details.
Okay, so we will get to that. If you this is and also we can use mutators for updating. Like for example, suppose that you want to update table transcript and you want to update the address of some people, all of the people who got whose student ID is 111 and course number is 532 and semester spring 2002. Okay, suppose that you want to set new values for these people. So in the update query, the where clause is similar. Okay, what you have here is in the where clause, you are where is this? What you have here is you are adding some conditions over here. Okay, and conditions. Okay, so far so good, but similar to what we had before. This student also refers to this guy, student. Okay, so we are in the for the rest of the query. We set a student, the object is student. We want to change the values for the address. We are using mutator for the address. And we want to change the value for name. We are using mutator for the name. So if you want to think object oriented, how do you interpret this in Java? Just think about this expression in Java. How do you interpret? If suppose that you have just this sentence in Java, okay, you have an object, a student, which has a function of name, which is changing the name. Okay, you call this function. What is it? What it returns? It returns. Sorry.
It is like a setter.
From this way. Suppose that you have a student. This student has a function address. Okay, this address is returning a new object. Replace replaced to the old object, okay? But the address value is changed, okay? So suppose that you have a student, you change the student the address of the student, now you got a new object. So again, you call another mutator name, okay? You can call it, right? So for example, you can call this function, right? You can call function name for this object of a student. This is object of a student, right? Because we know that mutator returns a new UTD. What is the UTD? The object of the student.
Those are like setter methods.
Yes, those are setter methods, but the setter method which returns the whole object. Okay, think in this way. Okay. Okay, now let's talk about the question Fanitra again asked it. So suppose that you have this table transcript. This student is the field the student is referring to a student, an object of a student, and the rest is as what we had before. Okay. Now the problem is if you want to insert a value to the table transcript for a pre-existing student, what is the solution? How can we do that? How can we refer to pre-existing student? We told that we don't have OID. OID is something kept by the DBMS. So what is the solution? If I give you the OID, you can solve this problem, right? You go to the table of a student, you find that person, like for example, suppose that you want to add a grade to Bahadur. Bahadur gets an A in database. Okay, what happens? So if you want to add a grade for him, so what you are doing is you are going to table a student, you find Bahadur's record object, you get its OID, bring it OID and put it over here, and the rest will be added. Okay? We are not creating a new Bahadur. Bahadur was there, but we are adding a new grade to him. So this is called self-referencing. However, we will see that this is not the thing that we are looking for. This is not exactly object-oriented. In object-oriented, we assume that at the beginning we had this assumption that there is no access to OID, but here we are breaking our assumptions. Okay, so this is called self-reference column. How I want to solve this problem? How I assume that every object of the student has in the table of students, we have another extra column which is self-referencing to the object, which is returning us to the OID. So then this is some sort of a new definition for create table. Now we define the table student 2, which is a set of the students of type student type, and ref is the student OID. Okay, so the student OID is the self-reference column referencing to object of a student. So this column is usually invisible to the users based on our assumptions, but now we are now adding this column to be used for the further. Okay, so then since we changed this object, this table of student, okay, and now we have this reference, then we can now change the table of transcript. So previously here, instead of referencing to a student, we simply put a student, right? But now we can add another reference over here. We add a reference over here. You see ref here to what? To a type, an object of a student type. And what is the scope? What is the scope? A scope is some sort of foreign key, defining foreign key. You have another table, the student 2, right? Where is it? Where is the student 2? The student 2 is here. I define the student 2 table, the student 2, which is a set of students, but it has this reference ID. Okay? Now, sorry. I'm defining a new table for transcript instead of using, what was the format before? We had just a student type. Now, instead of a student type, we have reference to student type, and we say that the scope of these references are student 2. It means that this student type is some object ID which is defined in a student 2. Okay, you can have several student tables. And the rest is similar to what we have before. Okay, so now the question, how can we query reference types? So we are making it more complicated and more complicated. We invented the object-oriented in order to make everything simpler, but now it's getting more complicated. So let's go and see what happens. So, and also, when we want to insert, how can we reference, or how can we put a value for references? Okay. So, first of all, we have one slight change. What is that? Think about reference type as a pointer. Now, the object is changed. In the student, in the transcript table, you see that in the transcript table, this attribute is not an object of a student. It's a pointer. So the first change we can see here is using the slashes, using dash greater than sign, in order to point to attributes. How many people have used object-oriented C++? How many people are familiar with object-oriented C++? Just one, two, a lot of people. Good. So you know what this arrow means, right? When do we use this arrow?
Pointers.
Pointers. When if the whole thing is a pointer, then instead of using dot, you have to use pointers. Here is the same thing, same syntax. And the rest of the query is similar. So the first change in the SQL queries, in the select queries, you have this change. Okay. Now, let's talk about insert. So, we want to insert some values to transcript. Instead of using insert values, what we are doing is we are using insert into select. So, in the select part, similar to inserting to select part, what we are doing is we need to select something for this guy. Select objects of this guy. So you remember that in the student OI, in student 2, we had an attribute, a student OID, which was a reference, okay, reference to self table, to objects of self reference, to object of the same table. So now, if I select, suppose that I want to insert the, suppose that this is a student ID of Bahadur, and I want to add this grade for Bahadur, like he got D in HIS 666 in fall 1462. It was very old. Probably in Harvard. Harvard, that's just Oxford. Some schools like this. Okay. Suppose that you want to add this record for him. But Bahadur looks very young over here. This is mine. So the first thing is I determine the rest of the attributes. The rest is similar to what we had before. this similar to inserting two values. You insert this value, and this value. The problem was the student. So what is the solution? I have to find this record which is referring to Bahadur's object. How? A select query. I say that this attribute is a student ID. It's a reference to a student, where this S is referring to
Yes,
table of students, and this is Bahadur's ID. So what happens is, basically, first this select will be executed, one record will be retrieved, that record will have the student ID or reference, and then this will be inserted. So, finally, is that clear now? Okay.
Basically, we are searching for the person, and then if he is there, then we are not adding a new one. If he is not there, then we are adding.
Right.
Basically.
Yes, this is solves the problem that you can now reference it. But in the old version, you couldn't reference a person because that the student was an object. We have to find out. Okay, so SQL 2003 is also adding this multi-set type of values. So what is this multi-set? What is this multi-set? It means that the values of this attribute is a set of objects to objects of course type. Okay, so one of the students, please just interpret or explain what this definition is, keeping in mind that multi-set means that it's a set.
It's a type
Uh,
that.
first of all, we are defining a new person, a new class.
Yes.
It's a class.
It's a type.
We are creating a new student type under a person type.
and
It means that
inheritance.
is it extending an inheritance of person. Okay, so
Yeah.
next. What kind of fields we have? We are
He
adding
is having a ID, status, and the courses he enrolled.
Multiple courses enrolled.
Multiple courses he enrolled.
yes, and this multiple course, this is a reference, right? Ref to course type.
Yeah.
No multi-set, just multi-set. Okay, so here we reference to. So this is getting more complicated, but don't worry about this. You can see more examples, and it will be very easy. So now, how can I query this multi-set? How can I query? Now we are adding one more complex stuff to our relationships. We are nesting relationship. One relationship inside of one of the attributes, it has a set. So it's a little bit more complicated, but don't worry about this. If you want to query this collection type, this sets, what we are doing is we are using a keyword called onset, which is stripping or extracting all of the values in this field. Okay. So suppose that you are okay. One person, can you explain what this query means?
We are selecting
Where, sir?
ID, address, and name from student table and course table.
First of all, what do we get in return? What are the
Three
fields?
attributes like
Three
ID,
attributes,
address, and name.
ID of the person, address of the person,
and name.
and the name of the courses he
Courses
he already enrolled. Okay. So okay. So far so good. So where can I find attribute, address, and ID? This field.
Student table.
Okay. Where can I find the name of the course?
course table.
Course table. Just remember that here this enrolled is a reference. It's not an actual course, it's a reference to courses. So now you, in order to get the name of the course, you have to get to another table. This is, okay, next. Just read this as a regular query. What happens? We have this course code in the where clause. If the where clause, this course code should be where this E,
In the enrolled courses,
right? What is this E?
it's the point,
It's a pointer.
Object the pointer.
But you remember that E was a list, a set. So I cannot easily do that. So what do I do?
You're pointing to the table original course.
Right.
To the,
So this onset converts this set to tables. Now assume that this E is a table of what? Of pointers to the courses that that person has already taken. Okay? So here, you put the course code over here. You have 10 minutes, just a simple example. Just in 5 minutes, just write a simple example to print out all of the courses the person, print out the name of the courses. Fanindra took in fall 2002, fall 2016. Write a query now to print out all of the name, all of the courses Fanindra has taken in fall 2016.
Where is the date located?
What?
Where is the date located?
Which table?
The date is in course code. Semester is in course code, right? No, sorry. Semester is not in course code.
yeah, it's another table.
Transcript.
Okay, so this is complicated. So just
More complicated.
writing a query to who is writing a query that is returning all of the courses Fanindra has taken from computer science department.
So course table contains even the department.
No, let me change the question, make it more interesting. Word pad. Write a query to print all of the courses and name of the people. Yes. Name and course name of students live in Bridgeport and courses are taught in computer science department.
So we need the schema of the tables first.
Okay, the course, just note that table course has this course name and also course department, which is a string, not an object. Okay? Make it easy. And also semester. No, not semester. And credits, number of credits. Is the question clear to everyone? Everyone understood the question?
No, we're required to print the student name and course name of students.
First name of the students who live in Bridgeport and courses are taught in computer science department.
And the address is in student table?
Yeah, address is in the student table.